So you're probably wondering, well, what was in Belcour's pragmatic chaos or the ensemble's algorithm that made them work so well? Well, it turns out that there's really hundreds and hundreds of ingredient algorithms that are really blended together in order to make it work as well as it did. So here we're not going to go through all of that. We're just going to illustrate the main ideas. Again, there's hundreds of ingredient algorithms. We're going to focus on specifically two of the main ideas that are kind of form the baseline in order to get there. Two of the main themes that they used. And the first one of them is the baseline predictor. It's no pun intended. I said before, forming the baseline. This does form the baseline for what's called the neighborhood model. And so basically, in the baseline predictor, we're going to just look at trying to use some sort of biases each of the users in order to make a prediction. So this is going to be something like user movie biases. So is this user an easy or harsh user? Is the movie well received, not well received, and modify the predictions accordingly? And in the neighborhood method, we're actually going to do sort of similarities. So we're going to say like user to user or movie to movie similarities. So for instance, if Charlie and Bob tend to like all the same movies, then we could say that if Charlie's going to like some movie, that Bob probably likes it too. And at the same time, movies could be like one another. So if you may have two different movies, two different Disney movies, for instance, like Aladdin and Lion King, right? And users tend to either like or not like them. So there, you can therefore say that if one user likes one of the movies, he's probably going to like the other one. And so now let's look at our example that we're going to be using to illustrate this. We'll stick to one example just to make it easier. And so in our example, we have 6 users, which we label A through F down the rows. Again, users down the rows. And we have 5 movies, 1 through 5, which we use Roman numerals to denote. The reason I did letters and then Roman numerals was so you didn't get confused with them, the actual rating values, which we'll use just numbers, 1 through 5 to do that. And so this table is a lot more dense than a Netflix table. We said before that Netflix really was a very sparse data set, right? So many entries are just not filled in. Out of the even 100 million entries that there are, there's just many, many more users and movies than there are entries when you consider all the different pairs that could be filled out in the table. And so in this case right here, we have all except for 5 of these filled. So really we have quite a lot of the data, and that's not going to be the case in real life, but this will suffice to illustrate the main ideas. And so we're going to section our data as well. Again, we have our training data, which are the numbers right here that are just written in black. So 5, 4, 2, 4, 4, and so on. Then the test data, we've bolded them and colored them blue. So for instance, 4 is in the test set, 2 is in the test set, 5, this 3 value and this 4 value over here, they're all in the test set. So what user C rates movie 1, we do know the value, but we're going to hold that off and make that part of a test set. And similarly with what user D rates movie 2. So we're not going to use those in developing the algorithm, we're just going to use them when we compare an RMSE on the predictions. And then there's unknown ratings, which we just don't have because the users just haven't watched or rated the movies yet. For instance, user E and movie 2, he hasn't rated that. User C, movie 3, this hasn't been rated, and so on.